Alright, so today we're going to be talking about solving polynomial equations. It's on your top of your paper, right? Solving. Okay. So last week and the week before that we talked about dividing polynomials and also factoring polynomials. Well, all of that was to prepare us for solving polynomial equations. Okay. So before we were given polynomials such as x squared minus 1, and we were asked to factor. Okay. So if we were asked to factor x squared minus 1, what method would we use? Can we use... I don't know, you tell me that. Is x squared a square? Is that a perfect square? Yes. What about 1? Yes. So yeah, you're correct. This is the difference of squares. Okay, so what do we know about the difference of squares? What will we get? Yes, so we'll have two binomials. We'll have positive, negative, so a plus and a minus sign. Okay, what's the first term? X. And what's the second term in each? 1. Okay, that's what we were doing last week. Well, now we'll be given x squared minus 1. It'll be given as a function. Okay, and they'll ask us to find the solutions. Okay, so now we're going to solve x squared minus 1 as an equation. So to solve x squared minus 1 as an equation, what we're going to do is we're going to set f of x, or we can always also interchange that with y. We're going to set f of x or y equal to 0. So we get 0 equals x squared minus 1. And we're still going to factor. Okay, so we already factored it. So we have 0 equals x plus 1 and x minus 1. Okay, now this is 0 equals something times something. So how do you get 0 when you multiply? How can you get 0 through multiplication? Yes, so either one of these can be 0 to give us 0. Correct? So what we can do is we can set x plus 1 equal to 0 and x minus 1 equal to 0. So we will get 0 x plus 1 equal to 0 and x minus 1 equal to 0. And now we have two binomials that are rather simple, and we can just solve for x. Okay, so to solve for x, we just want to isolate x. We'll get x by itself, and we'll subtract 1 from both sides, so we'll get x equals negative 1 and x equals positive 1 as our answers. And those are our solutions, or zeros. We call these zeros. Okay, so that's the main difference from what we did last week to what we're doing this week. Is now we're given our polynomial as a function and we're asked to find the solutions. So we're still going to factor, and once we factor them, before we would stop here. Now we're going to set this equal to 0 and find what x equals. Okay, are we good so far? Alright, so if we're given, just to work another one of these, if we're given the function xq plus x squared minus 6x. Okay, we're asked to find the zeros. Okay, we want to find the zeros. Our first step is to set the function equal to 0. So where f of x is, we're going to write 0. So x cubed plus x squared minus 6x is now equal to 0. What is our next step? Excuse me? We haven't factored it yet. So we have to factor it first. So if we're going to factor our equation now, what do we want to look for first? We want to look for x, so the greatest common factor. So what the greatest common factor of this is what? X. Yes, very good. So the first thing you always want to look for is whether or not there's a greatest common factor. In this case there is, and it's x. Okay. And if we pull out an x, this is a squared. Okay. So now, and it still equals 0. Now, have we completely factored this polynomial? Yes, so we still have a trinomial here that we can factor down further. Okay, so what method should we use since there's 3 terms? Close. I know what you're saying, but we call it the AC method. Okay, so the AC method, but we have to know ABC. So very good. You guys remember that? Alright, so are we going to be able to use the shortcut? Yes. Why would we be able to use the shortcut, Shad? Yeah, so the x squared is positive 1. Okay, so the leading coefficient of x squared is positive 1. So what's AC in this example? Negative 6. What's our B? 1. So now we have to find the factors of negative 6 that combine to give us 1. Okay? What will that be? What will the fact? Close. That'll give us negative 1. Yeah, there we go. So negative 2 and positive 3 will combine to give us 1. So this is a set of factors that we want to use. Okay, and since we can use the shortcut, since our leading coefficient is positive 1, we will get 0 equals x, the x is still there, x minus 2 and x plus 3. So we have x times x minus 2 times x plus 3. Is this now completely factored? Devin's shaking his head no. Why do you not think it's completely factored? Can you break any of these down any further? No. No. So it is. So once it's completely factored, what can we do? What should we do? Yeah, so set each of these equal to 0. Since this is multiplication, and we want to solve for x, we can set x equal to 0, x minus 2 equal to 0, and x plus 3 equal to 0. Okay? So x equal to 0, that right there is a solution. Okay? This x right here. Now, x minus 2 equal to 0. We'll add 2 to both sides, so we'll get x equals 2 as a solution, and then plus subtract 3 from both sides. So we'll get x equals -3. So those are our solutions. Okay. Do you notice anything about the degree of the function and the amount of zeros or the amount of solutions that we have? The highest degree and the amount of solutions. Do you notice anything? The degree. Yes. So if we have a cubed or a quadratic, or the highest degree is 4, that's how many solutions we'll have. So here we have x to the 3rd power. So, and since this is the highest degree, we have three zeros or 3 solutions. Before, we had x squared as our highest degree, and we had 2 solutions. Okay? So if we're ever asked to solve the equation or find the solutions or find the zeros, we should know how many we get just by the highest degree. Okay? So we can apply all of the methods that we've used to factor to solve or find the solutions. Okay? So the only thing we're doing now is just solving for x once we completely factor the equation. Alright, but today we're also going to talk about the rational root theorem. Okay, rational root theorem. And this is just going to be another method when all the other ones do not work that we can use to factor an equation. Okay? So all we're doing is just adding more tools to our belt. More tools that we can use to factor. Alright, so let's say that we were given the equation x cubed minus 8x squared plus 11x plus 20. Okay. And if we were asked to find all real solutions. Okay, say we were asked to find all real solutions. Say f of x equals that function. Alright? Based off what we know, what method do you think would work? Based off what we talked about last week, what method would you use? There's 4 terms. Yes, so we would factor by grouping. Okay? So let's go ahead and try that and see what happens. Alright, we have 4 terms, so we would factor by grouping. Okay? What would we factor here from the left side? Yeah, x squared. Okay. Well, what would we factor here? Is there anything we can factor? One. And if we factor the 1, do these match? Is this what we want? No, because we can't factor this out. So, instead of just throwing in the towel and giving up, we can use the rational root theorem. Okay? The rational root theorem says that when all our coefficients are integers, so all the are integers. No, this isn't. That our answer, the possible solutions can be written in the form of P over Q, such that P are the factors of the constant or in other words, this does not fit, or the last term and Q are the factors of the leading coefficient. It's probably the most words you've ever written in a math class. Okay, so P is the factors of the constant or the last term, and Q are the factors of, that looks like an I, of the leading coefficients. Did you have a question? Yeah, you can abbreviate this. Okay, and this is the case when all of our coefficients are integers. Okay, now what that's saying is when we find P over Q, that whatever we get, those are all the possibilities of our those are all the possible solutions. Okay, so what we want to do is, yes, you have a question? So the leading coefficient is that coefficient. So our leading coefficient for this function would be what? 1. And what's our constant or our last term? 20. Okay, so to the side right here, okay, we want to find our P over Q. Okay, so looking at P first, 20, we want to find the factors. So we're always just going to work our way up. So we're going to start with 1. Is 1 a factor of 20? Okay, not only is it 1, it's plus or minus 1. Why do you think it would be plus or minus 1? Exactly, if you have two negatives multiplied together, you'll get positive. Okay? Okay. And another thing we can do is, since we already know 1 goes with 20, we can write 20 out here. Okay, we can give ourselves some room. So we have plus or minus 20 as well. Okay? Now is 2 a factor of 20? Okay, so we have 2. And then we have 2 goes with 10. Okay? Is 3? It's 4. Yeah, so plus or minus 4. And then we know 4 goes with 5. And then those are our factors. Okay? Those are our factors of our constant. So now we want to find the factors of Q. So we said Q was 1, so what are the factors of 1? 1. So we have plus or minus 1. Okay? Once we get here, we then want to write this in a way that we can better understand. Okay? So now all we're going to do is going to just simplify. So what are the terms up here divided by 1? Yeah, they're just going to be themselves. So we're going to have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Okay? Now these are all the possible solutions to this function here. Okay? So what we can do is we can work backwards. If you guys remember synthetic division, we were given a root, and with that root we could divide the polynomial. Okay? So what we have here, we have solutions that we can test. Why do you think the rational root theorem is handy? What would be the purpose of using this if we can work backwards? What did the rational root theorem give us? Answers. So it gave us these are all the possible solutions or zeros that we can have. So yeah, we can use synthetic division and test these. Okay? So without this, we would have an infinite number of choices or infinite number of solutions to test. So now we only have how many? Close. It's plus or minus. So now we have 12. So how many? What would you rather have? 12 to test or infinity to test? 12. Yeah, me too. So what we're going to do is we're going to use synthetic division, and this is kind of what I said earlier, that what we learned the last 2 weeks is all going to come together. So we're going to use synthetic division, and we're going to test these until we find our solutions. So I'm going to draw our magical operator of synthetic division. Then we write our coefficients. Okay. And then in this box, let's test 1 first. Okay. So we're going to test 1. So we bring down the 1. Multiply. 1 times 1 is 1. Negative 8 combined with 1 is negative 7. 1 times negative 7. Negative 7. 11 and negative 7 combined. Yeah, you said 4. 1 times 4 is 4. 20 and 4. 20 and positive 4. 24. Yeah, it's positive 4. So is 1 a factor? I mean, is 1 a solution or a 0? No. Why not? What do we want our remainder to be? 0. Okay, so if our remainder is not 0, then 1 will not work. Okay, so now let's try negative 1. Just going to go through the process of testing these until we find one that works. Okay, so we have 1, negative 8, 11, and 20. Okay, bring down the 1. 1 times negative 1. Negative 1. Negative 1 and negative 1. I mean negative 8 and negative 1 combined. Yeah, we're combining them. We're not multiplying. So that's negative 8 minus 1 is negative 9. Negative 1 times 9. Alright, 11 and 9 combined. Yeah, 20. Negative 1 times 20. It's negative 20. So yay! What does that mean? We found the answer or a answer? One of them. Okay? So we found one of our solutions. Okay? So what's left here? What is this? Okay. That's what's left. But what does this mean? Okay, so yeah, this is x squared minus 9x plus 20. Okay, so this is the other factor that was multiplied by this to give us this polynomial. So what we have left, what we just did is we found out that x plus 1 times x squared minus 9x plus 20. This is the original that we started with. Okay, the original function. This is just factored out. Why do I have x plus 1 and not x minus 1? Well, what happens when we set x plus 1 equal to 0? What happens? Yeah, it will turn into, when we solve for x, we'll get x equals -1. That's what we said the root was, right? So when we want to write it as a factor, we have to make sure we put it back correctly, okay? So now we have, when we were originally asked to find all the solutions, so we want to set our function equal to 0, okay? We have 1. Now, can we factor this? Can we break this down further? All right, how would we do so? What method would we use? How many terms are there? Yes, AC method. There's 3 terms, so we can use the AC method. Okay? So, can we use the shortcut? Yeah, we can use the shortcut. Okay, so what is AC? 20. What is RB? So what factors of 20 can combine to give us -9? Very good. -5 and -4 combined to give us -9. Okay. And since our leading coefficient within these parentheses is +1, we can use the shortcut. So we still have x plus 1 out here. Then we have x minus 5 times x minus 4 equals 0. So is it completely factored now? Yes. So what can we do? We can set these, finish the sentence, we can set these equal to 0. Very good. So we can set, we already know what this one is. We already know x plus 1. That's the one we found earlier. X equals -1. Then we set x minus 5 equal to 0. Just add 5 to both sides, we get x equals 5. And then x minus 4, when we set that equal to 0, when we solve for x, we'll get x equals 4. And these are our 3 solutions, or zeros. And we started with a cubic, right? The highest degree was to the 3rd power, and we ended with 3 solutions. Okay? So that's the PQ method. Alright? It requires a little bit more, but it allows us to find these solutions to, an even larger set of polynomials. Okay? So do we have any questions about that so far? Are you guys good about that? Good with that? No? Okay. Alright. So now let's say we're given a function oh, okay. Okay. So in the middle, I'm just skipping. Okay. So if we had a polynomial to the 5th degree, we would have 6 terms. Do we know how to factor with 6 terms based off what we learned last week? Would we know how to factor that? A polynomial with 6 terms. Okay. So, what do you guys think we're going to use then? Yeah, so the rational root theorem. Okay? So now we're going to use the rational root theorem. Okay? And if we're going to use the rational root theorem, we have to, yeah, a whole sheet of paper ready. And we're going to find our P over Q. Okay? What's our P? Yeah, what's our P going to involve? P. What does P represent? So what's our constant? Okay, so you can think constant or the last term. Okay, what's our Q? 10. So our Q are the factors of our leading coefficient. So we now want to find those. Okay. So like you said, our P is 12. So what, starting from the bottom working up, is 1 a factor of 12? Yes. What about 2? 3? 4? 5? 6? And then 12, right? Okay. So now for Q, we want to find the factors of 10. So is 1 a factor? 2? 3? 4? 5? And then 10. Okay. So once we do this, we then want to write it in a way that we can understand better. So we basically want to simplify. So we're going to take each individual term on top, and we're going to divide it by the denominator. Okay. But it's going to be everything here divided by 1, and then everything here divided by 2, and then everything here divided by 5, and then everything here divided by 10. Okay? Does that make sense? So, if we start with the 1, everything divided by 1 will just be what? Yeah, just be itself. So we'll get plus or minus 1, plus or minus 2, plus or minus 3, and so on and so forth, all the way to 12. Yeah, do not write so on and so forth. So now we're going to do the same thing, but divide by 2. So 1 divided by 2, plus or minus 1/2. 2 divided by 2 is 1. Do we already have 1? So do we have to write it again? No. Okay. 3 divided by 2 is plus or minus 3 over 2. Just write it as a fraction though. Okay. 4 divided by 2 is what? 2. 6 divided by 2 is? And 12 divided by 2 is? We already have all those. Okay. So now we're going to do everything divided by 5. So we can get plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, 4/5, 6/5, and 12/5. After we do that, then we're going to do the same thing with 10. So we're going to get plus or minus 1/10 plus or minus 2/10. Do we already have that? What would that be? Yes, 1/5. Okay. So we don't have to write that one. What about plus or minus 3/10? Don't have that one, so we'll write that one. Do we have plus or minus 4/10? Okay. What about 6/10? What about 12/10? Yeah. Okay. So these are all our possible solutions. So once we get here, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you have 32. 32 is still better than infinity. It may be 32, but at least we don't have to do infinity. Okay? So once we get here, this is when we would then test and find out which ones are solutions or which ones are zeros. Okay? So that's the rational root theorem. Yes. So anytime any of the other methods do not work, we can't use AC method or factor by grouping or the sum or difference of cubes and squares, we can now use the rational root theorem to break it down. Alright? Guys have any questions? Alright, well your homework is page 246, problems 25 through 38. See ya.